So here's a step-by-step process I expect you to use. I'm not going to write it down for you. It's in your unit handout, but I do expect you to take notes on this list as I say it to you. When we're solving gas law problems, the first thing you're going to do every time, yes?
Which law are we doing? The boiling?
We're not doing any gas laws yet. First, I'm going to give you the system of steps for solving them, okay? All gas laws will be solved this way. First thing I want you to do, the first thing I require you to do, is to write a list of knowns and unknowns. Write a list of knowns and unknowns. Yeah, write a list of knowns and unknowns. Okay, that's the first step in solving these problems. If you don't have your test references already, you're going to need those. This is how we're going to solve gas law problems. We're going to start by writing a list of knowns and unknowns. Second step then is to choose the gas law that fits that list. Choose the gas law that fits that list and write it down. Choose the gas law that fits that list and write it down. So step 1 is to make a list of knowns and unknowns, and step 2 is to choose the gas law that fits that list and write it down. So now I've made it a little bit easy for you, because if you get out your test references, hint, hint, get out your test references, and look on this page, the same page that you have the solubility rules and the activity series of metals, you're going to find that all the gas laws you're going to use in here are found in this section right here. All the gas laws we're going to use in this unit, in this class, are found right in here. Okay? So choosing the correct gas law is as easy as looking at the knowns and unknowns list and finding the gas law that fits and writing it down. Okay? All right. The next major step in problem solving then is you're going to plug in your knowns into that equation. Plug in the knowns into that equation. Plug in the knowns into that equation. Yeah, Sydney, you're actually in the wrong seat. You need to move over into that row, and that's where Brenda's going to sit now. Okay, what I need you to do is to sign in and put that in your personal file, and your new seat is where Sydney is right now. Okay? All right. So we're going to plug in the knowns into that equation. Now, the next step we're going to do for solving all the gas law problems, the next thing we're going to do, the next major step anyway, is to isolate the unknown. I know you don't have any idea what that means right now, but you will shortly know what that means. We're going to isolate the unknown.
Is it like solving for variables?
That's part of the process we're going to use for solving for a variable. That's correct. Okay? But the way we're going to isolate the unknown cuts out this cross multiply divide step. In fact, if you want to write this down, you are not allowed to use cross multiply divide in here. Okay? Don't use cross multiply divide. I've had lots of students try. Half the time they get it wrong. And there are a lot of equations you can't use it with, and they try to use it when they can't. So they get those wrong. So we're never going to use cross multiply divide in here. Okay? Never ever. Verboten. Okay? Alright. So we're going to isolate the unknown. And then all the other steps are the steps you already know. Cancel units and species, or actually just units in this thing. We don't have any species to cancel. Cancel units. And in this case, we actually can cancel some numbers too. But we're going to cancel and solve. In the same way we've always been doing it. Cancel and solve. Okay? All right, couple heads up things, just to giving you an introduction to what you're going to see shortly. One thing you need to remember in problem solving here in this unit is whatever you do to one side of the equation, you must do to the other. Whatever you do to one side of an equation, you must do to the other. If you remember that, it's going to help you a lot. Whatever you do to one side of the equation, you must do to the other. That's a helpful thing to remember. Okay, another helpful thing that you may want to try to remember, it's not a problem solving step, it's just something you need to kind of remember in this process, is that you cannot solve directly for an unknown that's on the bottom of a fraction. You cannot solve directly for an unknown that's on the bottom of an equation, or I'm sorry, bottom of a fraction. You cannot solve directly for an unknown that is on the bottom of a fraction. You cannot solve directly for an unknown. You cannot solve directly for an unknown that's on the bottom of a fraction. Okay? Let's see. And one last thing, a little helpful thing. You cannot solve gas law problems that have temperature in Celsius. You cannot solve gas law problems that have temperature in Celsius, comma. So there's more to the sentence. You cannot solve gas law problems that have temperature in Celsius. You must convert to Kelvin. Excuse me. You must convert to Kelvin. K-E-L, capital K-E-L-V-I-N. You cannot solve gas law problems with temperature in Celsius. You must convert to Kelvin. All right, so we kind of laid the groundwork. Now let's start looking at some gas laws. Now the gas laws are actually listed for you, as I said, in your unit handout. First thing I want to do is just to use Charles' law to practice with. Now what's going to happen is the first few problems I'm going to give you will be Charles' law problems, so you already know what equation to use. But before we get to the test, you're going to have to be picking out the correct gas law that fits the question that's being asked. Okay? So we're setting it up to do that, even though in the beginning you're going to know what gas law to use. All right? Yes, you always use test references. No, you don't have to memorize the equations. However, you do have to be able to identify them by name. So you have to look at this and say, okay, that's Charles' law. And this is the combined gas law, and let's see, that's Boyle's law. When you look at them, you have to know what they are. But you don't have to remember the details of them, I guess, okay? Because they will be given to you on the references, all right? All right. So let's start with I'm going to give you a problem, and I'm going to show you how we're going to use this process then for solving problems. Let's say, let's see here. That cylinder I can't write today. Alright, so Ben has a cylinder filled with carbon dioxide. The gas volume is 2.25 liters, and the temperature of the gas is 15 degrees C, 15.0 degrees C. If the temperature is changed to 30.0 degrees C, and the cylinder's piston moves with no friction, what will the new volume be? So that's our beginning question. Yeah. I'm going to do it with you. Yeah, I'm not going to ask you to solve it at the beginning, okay? I'm going to do one for you, and then we'll let you solve one. I'm going to give you a couple more tips. Huh? This is a conversion type of problem, but it's not a conversion type of problem like the ones we've been doing up to now. Up to now, we've been starting with a starting amount and building our conversions to get to the final answer. Okay? But we are converting in a sense, yes. Okay? All right. So our first problem-solving step is to make a list of knowns and unknowns. And to do that, we have to kind of interpret the problem. Well, we don't have to kind of. You actually have to interpret the problem. So if we read the problem through, we can identify, and this is a good problem-solving strategy here. Underline your knowns as you go. Okay? You got 2.25 liters of gas, and that's the volume. Well, we'll use our symbol capital V for volume and say that's 2.25 liters. And the symbol for liters is a capital L. Okay? And reading the problem further, it says, and the temperature of the gas is 15 degrees C. So that's a T, capital T for temperature, and that's 15.0 degrees C. All right? And then let's see, if the temperature is changed, that's a new T. I can't have two T's. This is a new T. I'm going to call this T2, subscript 2, and the first one T1. And since the beginning volume and temperature go together, that's also V1 up there. Okay? So V1, T1, this is T2. It says T2 is 30.0 degrees C. Okay? And the question is asking, what will the new volume be? Well, this is a new temperature, and so this new volume goes with that. That's V2, and we don't know what it is. So we're going to write a question mark here because we don't know what it is. Okay? That's our list of knowns and unknown. Here's our unknown right here. Okay? Now, in some cases, there are actually more than one, but that's probably outside the scope of this class. All right? Now, so what we need to do, let's first find the equation that best fits this list of knowns and unknowns. So get out your test references. Let's look up here in this section and see if we can find a gas law equation up here that fits that list. Yeah, V1 over T1 equals V2 over T2. That fits that list of knowns and unknowns. You see that? Anybody confused by that? All right, so let's write that down. We're supposed to write it down. V1 over T1 equals V2 over T2. Okay? All right, so we're ready to start putting in, we're ready to go to the next step, but we got a problem before we do that. Yeah, we got to convert our temperatures to Kelvin. We can't use temperatures in degrees C, we said. Okay? Well, I was nice enough to give you that conversion right up here on this list of test references too. You really should know this, but just in case you're not quite sure, there it is. There's always going to be a conversion that uses 273.15. Okay? So if we have a temperature in degrees C, and we add 273.15 to that, we'll get a temperature in Kelvin. All right? So since we've got to change it to Kelvin, let's take this 15 degrees here, 15.0 degrees C, and add 273.15 to it to get a temperature in Kelvin. And using the process I taught you from Unit 1, we're going to keep our digits lined up nice and neat, 273.15, and we're going to add those together. And if you Notice there's an empty slot right there. So we know we're going to have to round off a digit at the end. 288.15. Okay. And since there's an empty slot in this column, the digit that results gets rounded off. So we're going to round this answer to 288 point, not 1, 0.2. 5, numbers 5 and above in the rounded off, first rounded off place, round up the digit it's next to. So this 288.2 Kelvin. So our temperature, initial temperature is, that we're going to, the way we're going to use it is 288.2 K. Alright? We're also going to need our final temperature in Kelvin. Okay, so we need to do that math as well. So 30.0 degrees C, and add 273.15 to that. You can do that now, right?
303.16.
Alright, so this is then 303.2 K. So now we have everything we need to actually start plugging in. So for V1, since we know V1 is 2.25 liters, we'll put 2.25 liters on top of the fraction. And T1 is 288.2 K. We're going to put that on the bottom of the fraction. So we plugged in our knowns into this part of the equation. V1 is 2.25 liters, T1 is 288.2 K. On the other side of the equality, then we know T2 is 303.2 K. That goes in the bottom. Oop. And then on the top, we don't know what that is. And what we're doing here is plugging in only the knowns, so V2 doesn't get changed. We leave that alone. Okay? Let's leave it at V2. So that's the third step. First step was make a list of knowns and unknowns. Second step was to write out the equation that best fits those knowns and unknowns. Third step was to plug in the known values we have. Okay? Now we want to isolate the unknown. So this is the step I said earlier you might not know what the term means. What we're trying to do by isolate means get something by itself. So we're trying to get V2 all by itself. Okay? Well, we're not going to divide here. We're actually going to multiply. The way we get V2 by itself is to multiply over here by 303.2 K. Now, one of those three things I told you at the beginning you need to try to remember is that whatever you do to one side of the equation, you must do to the other. So if I multiply by this over here, I've also got to do that over here. 303.2 K. Alright? And then what I said was the next thing you can do is to cancel. Well, notice I've got 303.2 K on the bottom and 303.2 K. That whole thing goes away. And I've got V2 all by itself. That was what I was trying to do, get V2 by itself. But over on this side, I can also cancel units of K here and here because they've got them on top and bottom. Well, because V2 is on top of a fraction where I've got 302.2 K on the bottom, and I need to get V2 all by itself. So by multiplying by this number on both sides, I can get V2 by itself. Yes?
So what you're telling me is like, if we was looking for T2, and we would have V2.
Well, if we're looking for, let's wait on that one. We're going to get to how you find T2, okay? One of the things I told you earlier before we started, one of those little tips I said, you can't solve directly for a variable that's on the bottom. We'll get to that, how you get past that problem. Okay? But right now, let's solve this one. All right? So you're going to need your calculator. So what we want to do is we don't have to solve anything on this side of the equation. We only got to solve what's over on this side. Okay? All right. So what we want to do is to take this number, 303.2, and multiply it by 2.25. And you want to hit enter or equals on your calculator. Uh-oh, what did I do wrong? Okay. And then, as a separate operation, once I do that, I'm going to hit divide and put in this number on the bottom. Okay. All right. Okay, so I get that V2, which is by itself now, I've isolated V2, is equal to 2.367106.176, and I kind of squeezed myself out here. I need liters in there somewhere. Okay, I could make it neater and say 2.367106.176 liters equals V2. Okay, that's just neat, making that neater. Okay. Yep.
You said that we couldn't do the cross multiply and divide.
Correct.
Why?
Because when we get to the more complex equations, cross multiply and divide falls apart on us, and I don't want you to get used to doing it now. This is like learning how to solve the problems in a simple way, so the more complex ones work out for us.
You round up?
Yeah, we're going to round it off. Yes, Sadie.
So which law would be it?
This is Charles' law. Charles' law. V1 over T1 equals V2 over T2 is Charles' law. Okay? All right. So looking back at our problem then, look at our measured and calculated numbers, and all of them are measured here. We've got 4 digits in this number, 3 in this number, 4 in this one. So since this number has the least digits, that's how many digits I want in this answer, because it's a multiplication and division problem. Okay, so we want to count 1, 2, 3. Those are our significant digits, and underline everything after that. Draw an arrow to show that we're rounding off, and write our rounded off final answer, 2.37. The 7 causes the 6 to round up. Liters equals V2. And there's the answer we're looking for. Okay? Yes. I'm going to give you another one and let you solve it now.
Do for grade and stuff.
I don't think we're ready to do it for grade.
Yeah, we.
I don't think we're ready to do it for grade.
Y'all trust us. Y'all believe in us.
I think that there are some people that are getting this really easily and some people that are struggling with it a little bit still. So let's just give everybody a chance to catch up, okay? We got to look out for everybody.
Are we going to use that same equation for every one of them?
No. No. Eventually we're going to have other equations and you have to figure out which one to use. Say what? Let's find out. If you use the process I taught you, you will know. Yes.
The problem you got the homework is really like that, or they more complicated?
Let's just wait till we finish the class. When we finish this class today, you'll be able to do the homework problems. Okay? All right.
It used to be wrapped in plastic and it fell. Oh, yeah.